welcome to True Projects. In this video, we are going to discuss about the project which is deep learning model for recognition of handwritten Devanagari numerals with low computational complexity and space requirements. So before getting into the execution, let us understand what are these Devanagari numerals and why should we recognize these handwritten Devanagari numerals. So coming to Devanagari numerals, they are just numerical symbols used in Devanagari script. And this Devanagari script is primarily used for writing several Indian languages that are Hindi, Marathi, Nepali, and Sanskrit. The Devanagari script is an abugida, which means that consonant vowel combinations are represented by just a single character in Devanagari script. Similarly, the numericals in Devanagari are also distinct characters representing numerical values. So why should we recognize these handwritten Devanagari numerals? With over 528 million Indians considering Hindi as their primary language and growing number of users are increasing, the need for efficient automated recognition systems for Devanagari characters is crucial. So recognizing this handwritten Devanagari numericals is super important because it helps in preserving our culture heritage and aids in digitizing historical documents efficiently. And it is not just about culture and history, it is also about making things easier. It is also important because it has practical applications in sectors like banking, where handwritten numericals may appear on checks or forms. So, developing accurate and efficient recognition systems for these numerals streamlines processes and improves overall efficiency. So, that is why in this project, we are going to develop an efficient system that will accurately classify and detect these Devanagari numerals using machine learning and deep learning models. So the author in the base paper, he has proposed a technique called Swin transformer to recognize handwritten Devanagari numerals. And this Swin transformer is finely tuned with the standard popular DCNN models that are VGG16net, ResNet 50, and DenseNet 121. So to further improve the performance, we have employed the model called Exception, which is deep learning model for classification of handwritten Devanagari numerals. And for detection, we have used the technique YOLO, which is you only look once, which is object detection algorithm. Moving on to the flow of the project, we started by exploring Devanagari character dataset to understand its composition and characteristics. And then we delved into image processing techniques. That is, we applied methods like data augmentation using image data generator and torch vision based processing for tasks such as resizing, transformation, and reshaping of the Devanagari character dataset images. Then came the exciting part, where we built multiple models for both classification and detection tasks. For classification, we utilized CNN with Swin Transformer, VGG16, ResNet 150, DenseNet 121, and Exception. And for detection, we experimented with various versions of the YOLO. Once the models were built, we trained them on pre-processed dataset to learn patterns and features of Devanagari numerals. After training, we evaluated the models. We assessed the classification models using metrics like precision, recall, and FN score. And we evaluated detection models using mean average precision, recall, and precision. Finally, after ensuring everything was in order and sorted out the best performing algorithm, that is exception for classifying Devanagari numerals, and for detection, YOLO, we integrated Flask framework with SQLite to deploy the project. So moving on to the requirements of the project, we need software and hardware requirements to implement the project. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And the hardware requirements are Windows operating system, processor of i5 and above, 8 GB and above RAM, 25 GB and above hard disk. Moving on to the algorithms used, these are the models built for classifying handwritten Devanagari numerals, and these are the versions of the YOLO built for detection of handwritten Devanagari numerals. In classification, along with exception, we also built the base paper's proposed model. It is because to see how well the exception is performing well than Swin transformer techniques. So let us know what is this exception. Exception is a deep learning technique and it is known for being good at understanding images. And it does this by breaking down the process of looking at images into two main steps. First step is to look at different parts of the image separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. This helps exception to understand images better and pick up on important details. This methodology enables exception to grasp nuances within handwritten Devanagari script images effectively, thereby enhancing classification accuracy. Notably, its efficiency is paramount in handling large volumes of images, which is crucial for tasks like numerical recognition. Furthermore, exception helps excels in identifying significant features within the images, optimizing the performance in our project. So moving on to the YOLO. YOLO, it stands for You Only Look Once, and it is a state-of-the-art object detection algorithm that processes images in real time, providing a fast and efficient method for identifying objects within them. And it operates by dividing the input image into a grid and predicts bounding boxes and class probabilities directly from the grid. Unlike traditional object detection methods that require multiple passes over an image. YOLO, it performs detection in a single pass, directly predicting bounding boxes and class probabilities for multiple objects simultaneously. This approach makes YOLO particularly well suited for all the applications which require real-time processing. Although all versions have similar objectives, they differ in their architectures. So coming to YOLO V5, it uses CSPD Darknet 53, which is backbone for efficient feature extraction, and PanNet NEC for feature fusion at different scales. Moving on to the YOLO V6. YOLO V6, it prioritizes even faster backbones and simpler NEC structures compared to V5 for real-time needs. Specific details are undisclosed. So moving on to the YOLO V7. It is built upon V5's architecture by incorporating elements for both speed and accuracy. It involves modification to backbone neck or head for this balance. The last model is YOLO V8. It explores anchor-free detection for faster and more adaptable object localization. As YOLO V8 is performing well, so we deployed it in the front end for Devanagari numericals detection. So now we will execute the project. To execute it, first we have to open the code folder which contains source code files. These are the source code files in the code folder. So let's understand each file. How will it be used in the project? So in this folder, we have the data set, that is Devanagari script used in the project. So from N0 to N9, we have numerals of Devanagari script. And from V1 to V12, we have vowels of the Devanagari script. So in the N0, we have images related to Shunya, which is 0. And here in the N1 folder, we have images related to Ek, which is 1. And here we have images related to Do, which is 2. Similarly, we have Teen, which is 3. And in this folder, we have 4, which is Char. And here we have 5, which is Panch in Devanagari script. Che, which is 6 in Devanagari script. Sat, which is 7. 8 and 9 simultaneously. And here we have in V1 A. So here we can see A. These are the Devanagari vowels. So we have from A to AHA. So here in this last folder, we can see AHA. Get back. So we split all these images from all the folders into train and test sets in the ratio of 70:30. Now these train and test sets are stored in the output folder. So here in the output folder, we can see train folder and test folder. Sorry, validation folder. So we use this train folder to train all the algorithms built in the project. So we build classification models using this train set, and we evaluate all the classification models built using this validation set. So get back. Moving on to YOLO V5 folder, we have data set related to detection. Here we can see train and test sets. So here in the train folder, we can see two subfolders. One is images and the other one is labels. In images folder, we have images related to all the Devanagari numerals as well as Devanagari vowels. So we use all of these images to train the YOLO V5 algorithm. Get back. Here in the labels folder, we have files containing annotations and labels for objects in corresponding images. So here, each label file, it corresponds to an image file in the image folder. So this file, it corresponds to this image, and this file corresponds to this image, which provides details about object locations and classes within the image. Similarly, for each image folder, we have each label file. So get back. All these label files, they follow the YOLO format. And here we can observe each line, it represents a detected object. Here in this line, this is the object class index and it is followed by its bounding box coordinates. So these are the bounding box coordinates which are normalized to an image dimensions. So this is the X limit, this is Y limit, this is width, and this is height. So now close this, get back. Similarly, in the test folder also, we have two subfolders. One is images and labels. We use train folder to train the detection models and the test folder to evaluate the detection models. So get back. So similarly in YOLO V6, YOLO V7, and YOLO V8, we have the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized and ensures that each YOLO version receives the correct annotations it needs to function properly. And here in the sample folder, we have two subfolders. One is classification and the other one is detection. In classification, we have all the classes of Devanagari numerals as well as Devanagari script. So we used all of these test cases to detect in the front end. Here we have images related to detection. So we use all of these images to detect Devanagari numerals as well as Devanagari vowels. So get back. This is the static folder. This folder contains files related to the project styling and interactivity, and those files are CSS, JavaScript, and Bootstrap files. These files, they are crucial for enhancing the visual appeal and functionality of the project's web interface. So moving on to the templates folder, here lies all the HTML pages used in the project. They are index.html, about.html, etc. Each HTML file represents a different page of the website and provides the structure and the layout for displaying content to the users. This is the app.py file. This Python file encompasses the front-end logic of the project, and it handles server-side operations including processing user requests, interacting with the database, and dynamically generating content that to be represented in HTML templates. These are the model files which contain the algorithm information and they will be loaded into the project code during runtime. These two are the notebook IPYNB files. These are the Jupyter notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making popular choice for the data science. And this last file is the signup.db file. This file is a database file which is used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. So here, using the command cd space followed by the path which is copied. And now we need to click on enter. This will change current directory to the code folder's path. So here we can observe current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and then click on enter. This will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flash framework will host the application locally at the default address, which is the local host and the port unless configured differently. This is the local host and this is the port. Now we need to copy this local link provided by the Flash framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flash framework. So first we need to sign up. So click on sign up link and enter all the registration details if you are registering newly. I have already registered and I have an account in it. So I will directly sign in. So click on sign in. Here we need to provide username and the password. So I'm giving my username and the password. Now click on sign in. I have signed in successfully and I'm redirected to prediction page. I already told you that we're going to do classification as well as detection of handwritten Devanagari numericals. So first we will do classification. For that, under prediction, click on classification. Here we can see a choose file button. We need to click on that for uploading the images of Devanagari numerals. So click on choose file. So here in the sample folder, we have two folders. So we'll be using classification folder for uploading the images as we're going to do classification of Devanagari numericals. So first we will upload number 0. So I'm opening the first folder. I'm going to upload this image. So click on open. Here we can see image has been loaded. Now click on upload. So here for the uploaded image, we got the prediction that Devanagari number is 0. It is called as Shunya in Devanagari numericals, in Devanagari script. So now we will upload one more Devanagari numericals. So click on classification, click on choose file again. This time we'll be uploading from this folder. So I'm going to upload this image, which is 1. So now click on open. Here we can see that image is loaded. Now click on upload. So here for the uploaded Devanagari symbol of Devanagari numerals, here we got the prediction as Eka, which means 1. So here we can see that Devanagari number is 1, which is called as Eka in Devanagari script. So this is the symbol for 1, that is Eka in Devanagari numerals. So now we'll upload some more numericals. So click on classification, click on choose file. Now we will upload number 2. So I'm going to open the third folder. I'm going to upload this symbol of Devanagari numerical 2. So click on open. Image is loaded. Now upload it. Here for the uploaded image, we got the prediction as 2, which is called as Do in Devanagari script. So now we will upload some more images. So click on classification, click on choose file. Now we will upload the theme, which is 3. Now click on open. Here image is loaded. Now click on upload. Here for the uploaded Devanagari symbol teen, it has correctly classified as the Devanagari number is 3, which is called as teen in Devanagari script. So now we will upload some more images. In prediction, click on classification. Click on choose file. This time we'll be uploading this image. Click on open and click on upload. So here for the uploaded Devanagari symbol, that is Devanagari numeral, we got the prediction as the Devanagari number is 4 and it is called as char in Devanagari script. So it has correctly classified this char. So now we will upload some more images. Click on choose file. I'm going to upload from this folder, which is 5. Click on open. Here for the uploaded symbol, we got the prediction as the Devanagari number is 5, which is called as Panch in Devanagari script. So it has correctly classified this Panch, that is 5. We will upload some more images. Click on choose file. This time we'll be uploading from this folder. So I'm going to upload this image. Click on open. Image is loaded. Now upload it. Here we can observe that for the uploaded image, we got the prediction as the Devanagari number is 6, which is called as Che in Devanagari script. Now we will upload some more images. Click on choose file. This time we'll be uploading from this folder. So I'm going to upload this image. Click on open and now upload it. Here for the uploaded image, we got the prediction as the Devanagari number is 7, which is called as Sat in Devanagari script. So now we will upload some more Devanagari numerals. I'm going to upload from this folder, which is 8th folder. So I'm selecting an image. Here for the uploaded image, that is the uploaded Devanagari numerical symbol, we got the prediction as the Devanagari number is 8, which is called as art in Devanagari script. So we'll upload one more Devanagari numeral image. Click on classification. Click on choose file. So we'll be uploading from this folder. So I'm going to select this image. Here for the uploaded image, we got the prediction as the Devanagari number is 9, which is called as now in Devanagari script. As we classified the Devanagari numerals, now we will classify the Devanagari vowels. So click on classification again. Click on choose file. So in V1 folder, we have vowels of Devanagari numerals. So I'm going to upload this image, open it. So here for the uploaded image, we got the prediction that this is Devanagari vowel A. So as we did classification, now we will do the detection. For that, under prediction, click on detection. Similar to classification, here also we have choose file. We need to click on that for uploading the images for detection. So click on choose file. Now we will upload the images from detection folder. So open it. I'm going to upload the first image, which is Shunya, and we will see how will it correctly detect. So click on open. Here we can see that it has correctly detected Shunya, which is 0, and it has drawn a green color bounding box around the 0, and it has labeled it as 0. Now we will try uploading some more images. Click on choose file. This time we'll be uploading this image. Click on open. So here it has correctly classified the Devanagari numerical symbol as 1, and it has drawn a bounding box around it, and it has labeled it as 1. So now we will upload some more images. Click on choose file. This time we will upload the symbol 2. So click on open. So here we can see that it has correctly detected and drawn a bounding box around the 2, which is called as though in Devanagari script, and it has labeled it as 2. So now we will upload some more images. Click on choose file. So now we will upload this teen symbol of Devanagari numerals. So click on open. Here we can observe it has detected teen as 3, and it has drawn a bounding box around 3. It has correctly detected. Now we will upload some more images. Click on choose file. Now we will upload the symbol 4 of Devanagari script. This is the symbol of 4. Open it. Here we can observe it has detected correctly and drawn a bounding box around it and classified it as 4. Now we will upload some more images. This time we'll be uploading this image. So here we can observe that 5 is detected and a bounding box is drawn around 5. And this is the symbol of 5. Now we'll upload some more images. Click on choose file. So now we will upload this image. Open it. Here we can observe that The application has detected 8 and drawn a bounding box around the symbol 8. Now we will upload vowels of Devanagari script. So click on choose file. So this time we'll be giving the symbol, that is A. Click on open. So here we can see that A is correctly detected and a green color bounding box is drawn around it. And here we can see label of it, which is A. Now we'll upload some more vowels. Click on choose file. So this time we'll be uploading this vowel. Open it. Here we can see that it has correctly detected the E and a bounding box is drawn around it, and it has written in English as E. So now click on choose file. This time we'll be uploading this image, which is U. Open it. Here we can observe U is correctly detected and a bounding box is drawn around it, and it is labeled it as U. Now we'll try uploading some more images. So this time we'll be uploading this image. Open it. Here we can observe that it has correctly detected I and drawn a bounding box around it, and it has labeled it as I. In this way, just by uploading images that are Devanagari, numerals as well as vowels to the system, it will correctly detect and classify those numerals as well as vowels. So now we will see graphs of the project. Click on graph link. So first we have graphs for classification. These are the loss and accuracy curve graph of exception. This is the loss graph and this is the accuracy graph. Here, blue color line represents training loss and the red color line represents validation loss. And here, blue color line represents training accuracy and red color line represents validation accuracy. This is accuracy comparison graph where on x-axis we have accuracy score of each algorithm and on y-axis we have algorithm names. This is precision score comparison graph, and this is recall score, and this is F1 score. And here we have graphs for detection models. This is F1 score of YOLO V8. This is the F1 confidence curve graph. Here on x-axis we have confidence score and on y-axis we have F1 score. And this is precision recall curve graph where x-axis represents recall and y-axis represents precision. This is confusion matrix of YOLO V8 algorithm. And this is precision score comparison graph. This is recall. This is mean average precision. So now click on sign out.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.